Transistor is a three-terminal semiconductor device that is used mainly for amplification or switching purpose. You may see such like shape in the electrical circuit that consists of the three conductors originating from this body, which represent us that inside this body we will have three regions. That three regions is represented by the diagram here. The first region is called the emitter, the intermediate region is called the base, and the last region is called collector. If this transistor is in PN transistor, it means that the first region we call the emitter will be made by the N-type semiconductor material. The intermediate region, which we call the base, will be made by the P-type semiconductor material, and this last region is made by the N-type semiconductor material. As we have discussed the P-type, N-type semiconductor materials in more detail in the previous lectures. Okay, so the symbol for the NPN transistor is this. These two wings represent the emitter and collector, and this region represent the base. Here towards this emitter we have this arrow which represent us that here in the base we have the P-type semiconductor material. Is we know that from the positive charge particle, electric field lines will be originating. Just like that, we have the P-type material here, and this electric field lines are just like that. This arrow is originating from that and terminating here in the emitter. Okay, such like. Symbol will represent us that in the circuit we have the NPN transistor. Similarly, we have also the combination as PNP transistor. If we have the PNP transistor, it means that the first region we call the emitter will be made by the P-type semiconductor material. The second region, which we call the base, will be made by the N-type semiconductor material. And the last region, which we call the collector, will be made by the P-type semiconductor material. The symbol for this PNP transistor is this. Okay, here these two wings represent the emitter and collector, and this represent the base. As I have discussed here, that in the base towards this emitter from the base we will have this arrow like shape, but in this case it is towards this base. Okay, it represent us this, and that in base we have the N type semiconductor material. Just like in the negative charge, the electric field lines is terminating. Okay, so here towards this base, this line is terminating. This arrow is towards this base, so it represents us that in the middle we have the N type semiconductor, and on both side we have the P type semiconductor material. Okay, so this sort of the transistor we call as bipolar junction transistor. Such type of the transistor in the circuit, their conductivity will be depend upon the minority charge carrier and also on the majority charge carrier. Okay, so if we see this material on the basis of the size, so as I have discussed, this device has three regions. So which region have larger size? Okay, so here is the pattern for the collector will have the larger size. So as I have draw here, this collector have more size, okay, as compared to this emitter and the base. So after the collector, the size will be greater for the emitter and very less size will be for the base. Okay, so this is the pattern for the collector size will be greater than the emitter side, that will be greater than the base size. Okay, if we see this device with respect to impurities, if we see the portion inside this device with respect to impurities, that this will be the pattern in that. So the impurities in the emitter will be greater than the collector. Okay, and the impurity of the collector will be greater than the base and will be less than the emitter. So here what I am going to mention is that on the basis of impurity, we have this pattern mean that the emitter will have more impurities. It will be more doped. Okay, the emitter have more impurity than the collector, and the last one is the base. So from here we conclude that the base is less doped and having small size, the collector having large size and less doped as compared to the emitter. Okay, emitter have less size as compared to the collector, and highly doped. It consists of the more impurities. Okay, the other sorry, if we connect the external voltage to this, okay, so we have that external voltage here is this is the voltage between the base and the emitter, so therefore we call this voltage as VBE. And similarly, if we connect the battery and the voltage, if we provide the voltage, so if we connect one terminal of the battery to the base and the other terminal to the collector, this voltage will now call the base collector voltage. Base collector voltage. Okay, so this is actually that transistor having three conductors originating from their body, and inside that we have these three regions as represented by N, P and N. Okay, and they have these three terminals. The first terminal is connected to this B base is common for these two, and we have two battery source for this. Okay, in the transistor, you have to remember that in the transistor, this base, if here we have the junction between this uh, n-type material and the p-type material, we call them as a p-n junction. Okay, inside we have the depletion layer, the potential barrier, and all this stuff which I have discussed in previous lecture. Okay, so we have that p-n junction. Okay, so you have to remember in the transistor, the base, this is actually the emitter base junction will be forward bias. Okay, and the base collector junction, this junction will be the reverse bias. And as I have discussed in the previous lecture, that if this junction is reverse bias, this potential barrier will be more, the electric field will be more. Okay, and this depletion layer will be greater. Okay, it will be more. Okay, so here this emitter to base junction will be forward bias, this base to collector junction, base collector junction will be reverse bias. Okay, so what does I mean by the biasing here is that by the forward bias I mean that the negative, if we connect the negative terminal of this battery with the N-type semiconductor material and the positive terminal of the battery with the P-type semiconductor material, then this arrangement is called the forward biasing. And here this depletion layer will be less, and the electrons, this majority charge carrier, will be allowed to cross this barrier. On the other hand, here if we connect the positive terminal to the N-type semiconductor material, the negative terminal to the P-type semiconductor material, this negative terminal will attract the holes which is in majority in the p-type semiconductor material towards itself. Similarly, this positive will attract these electrons towards itself, and as a result this p-n junction will be increase in their size. Okay, so therefore this is a reverse bias. Okay, so here in the transistor, the emitter to base junction will be the forward bias, and the base to collector junction will be the reverse bias. Okay, so if we provide the voltage, and if we provide this voltage, then the current will start in this device, in this transistor. Okay, the current will be start from this emitter. Okay, from this emitter, here we have more impurities, and this is the forward bias, so therefore the current will start from this emitter, which we call that IE. Okay, some of these charges as electron as majority charge carrier will be across this p-n junction, because here we have the forward biasing and will reach here to the base. In the base, which is less doped, consists of less number of the holes. Okay, and that electron will be recombined here in this hole, and this process is called recombination, and due to this recombination the current IB will be produced here in this section, which we call that current as IB. So some of the current IE will be transferred to IB. Now that remaining electrons, that remaining charge carrier will be cross this potential barrier. Okay, so as this electron can cross across this reverse biasing. Okay, here. So that remaining charge carrier will be start flowing towards this collector, and due to which the current is called IC. So here, if we take 100% electrons, then only 1% of that electron will be converted into their motion will be converted to IB, will form the IB, the correct base current, and the remaining 99% electrons will be contributed to IC here. Okay, so this is that. Now this is that combination, and due to this we can say that emitter inject electron in the base region, where some of them recombine with the holes here. This emitter inject the electron towards this space, and that is recombined here in this hole, and the large number of electrons are attracted towards this cathode due to this high potential. Okay, this VBC is greater than this VBE, so therefore that electrons is attracted by this positive terminal towards itself. Okay, so when emitter current, this IE flow, a very small amount of the current electron will be contributed to IB. Okay, that due to the recombination, and very less, and the remaining electron will be flow towards the collector, which we call the IC. The current through that is called IC. So here in this equation, IE is equal to IB, which is less, plus IC. Okay, so we have that simple diagram here. This is VBE, the voltage between the base and emitter, this voltage between the collector and the base. As we have discussed, this combination, this voltage is greater in magnitude as compared to this voltage. So from the sign it also represent as that. Okay, so here this collector to base junction will be reverse bias, and this emitter to base junction will be the forward bias, and this is actually the PNP transistor, in which we have the holes as a majority charge carriers. So we have on the other hand the NPN transistor, and this is the circuit diagram. For that we have that same scenario which I have discussed here. These are the positive and negative, and now if we see and if we compare this with the previous diagram here, okay, NPN, this NPN, the current is opposite to that of this one. Okay, because here the current IE is from left to right, and in this case that is from the right to left. Okay, that current is from the right to left. So why is so? This is in our KPK book we have this diagram. This is here this diagram is based on the conventional current, and that was for the electronic current, and there is no other difference for that. Okay, now this is the diagrammatic, this is the circuit diagram for the PNP transistor, and here the current is opposite of that of NPN transistor, because Here the majority charge carrier is the hole, and in that case the majority charge carrier was the electron. Okay, so therefore the current has opposite to that of the electron. Okay, so if the electron is moving in this direction here, sorry, there we have the conventional current, so this PNP has opposite, just opposite direction is that of the NPN transistor. Okay, so here in this circuit we have the one mistake is that if we consider this is the emitter side, and in this emitter side we will have some arrow. Okay, so if the base is the p-type material, the arrow will be towards this emitter. Okay, so here we need to have the arrow which is towards the emitter, but in this case in the base region we have the n-type semiconductor material, and the arrow will be from the emitter towards this base. Okay, so this was the detailed explanation and the physics behind the transistor, as we have discussed here. And due to this arrangement, the this device, this transistor is used for the amplification purpose that we will discuss in the next lecture. And this is also used for the switching purpose, as we have in the computer we have CPU. Okay, that CPU is made up of millions of the transistors. Similarly, we have GPU. That GPU, the graphics card, the processor in your computer is consist of the millions and billions of the transistor. Why we use the transistor in that CPU? Why the transistor is present here? What is the functionality of the transistor there in the CPU and GPU? This is actually it is used their switching capabilities there. Okay, as we know that we have the computers operate on the binary numbers 0 and 1. That 0 1 is actually the switching property, represent the switching property, and that 0 1 capability, the functionality of the computer is provided by the transistor. Okay, so therefore transistor is the most important component in the modern technologies. Okay, most important electrical, this is the element in the electrical circuit in the modern technology. Okay, so this was the brief explanation about transistor, and that's it guys. Thanks for watching.